Good morning, everyone. So welcome to my YouTube channel message. So today we are going to see set lecture on asymptotes of curve. Okay. In this lecture, we will study how to find uh, asymptotes of the curve of a particular form. Okay. Let's see. So a general form of the curve is given by the general equation for a curve in two dimensions x and y is given by gxy is equal to 0. Okay. So we are taking, so we are, taking the case finding the asymptotes of the curve gxy is equal to 0, solvable as y is equal to fx is equal to px upon qx. It means, what? Y is an explicit function of x. Okay. So first we will take this case where y is solvable for function of x. It means y is explicit function of x. Okay. So I am writing in bracket y is function of. So how to find vertical asymptotes? So vertical asymptotes. So we are taking this curve. We had already told that we are taking this case. Here px and qx need not be polynomial. Okay. I am writing like that, but it is not. So p and qx need not be polynomials. Now how to find? So if limit x tends to a, fx is equal to plus minus infinity, then x is equal to a is a vertical asymptote of the curve. Okay. Or of the curve, this curve. Okay. So this is the process of finding vertical asymptote. Now how to find uh, horizontal or oblique asymptotes? Oblique asymptote. Okay. So we are finding horizontal vertical asymptotes of this function. How? Consider y is equal to ax plus b. Okay. If both the limits if both the limits both the limits limit x tends to plus minus infinity y upon x, okay, and limit x tends to in plus minus infinity y minus ax is equal to b exists, then y is equal to ax plus b is an asymptote of the curve. Okay. In this case, if a is equal to 0, then y is equal to b is horizontal asymptote, and if otherwise y is equal to ax plus b. Yx, it means in that case a is not 0, is vertical, oblique is oblique asymptote of the curve. Okay. Okay. So if in this case, if this limit is infinity, then x is equal to a is a vertical asymptote. And how to find horizontal oblique? To calculate limit y upon x tending to plus minus infinity, even it is both the and limit x tends to plus minus the y minus ax is equal to b exists, then y is equal to ax is an asymptote of the curve. In this case, if a is 0, then y is equal to b is horizontal asymptote. Otherwise, y is equal to ax, because otherwise case will be where a is not equal to 0 is oblique asymptote of the curve. Okay. So it will be clear by example. Okay. So also note that if any of a or b do not exist, then no horizontal or oblique exists. If any of A or B does not exist, then no horizontal asymptote exists. Okay. So we will see it by example. Okay. See this example. Y is equal to x square minus 2x plus 1 upon 2x plus 3. So you see that only problem is at x is equal to 3 by 2. Limit x tends to minus 3 by 2. What is the limit of? This is my fx. What is this limit? This is nothing but plus minus infinity. So this implies x is equal to minus 3 by 2 is vertical asymptote for the given curve. Okay. For the given curve. So vertical we have found. Now we have to find horizontal or oblique. So limit, you check limit x tends to plus minus infinity. Y upon x, what is this? This is limit x square minus 2x plus 1 upon x 2x plus 1 upon 3. So this limit is nothing but 1 by 2. Let's calculate it. So limit. So take x square common. So it will be so this is cancelled out. So what will be the limit? Limit will be 1 upon 1 by 2. So this limit is exist. We are calling it this exists. Now what is B? B is equal to limit x tends to plus minus y minus ax. What is this? What is y? X square minus 2x plus 1, 2x plus 3 minus 1 by 2x. So solve it, what we will get? Two x square minus 4x plus 2. And this is 2x square minus 3x. So this is cancel out. And this is 2x plus 3. Limit x tends to plus minus infinity. This is minus 7x plus 2. And this is 4x plus 6. Now take x common outside. So what you will get? Limit x tends to plus minus into x 7 plus 2 upon x, 4 plus 6 upon. So what is this limit? Minus 7 by 4. This limit also exists. So both the limits exist. So y is, this implies y is equal to ax plus b, that is x by 2 minus 7 by 4. It means 4y 2x minus 7 is vertical asymptote, sorry, oblique asymptote for the given curve. You see that when we calculate in this case the oblique asymptote, automatically horizontal asymptote is also calculated. But here no horizontal asymptote is coming. So because only vertical, only oblique asymptote is coming. So no horizontal asymptote exists. No horizontal asymptote exists for the given curve. Example 2. Y is equal to x upon x square minus 4. We need to find its asymptote. You see that limit x tends to 2. What you will get? What is this? This is my fx. So what is this limit? This limit is nothing but plus minus infinity. So this implies x is equal to 2 is a vertical asymptote for the given curve. Okay. Now similarly check limit x tends to minus 2 fx. Because you see that denominator is 0 if and only if x is, denominator is 0 if and only if x is plus minus 2. You put the denominator equal to 0, you will get x value plus minus 2. That is why we are calculating like that. This is also plus minus. So this implies x is equal to minus 2 is a vertical asymptote for the given curve. Okay. Sorry. Now we need to calculate horizontal or vertical asymptote. So we have to calculate limit. Limit a is equal to x tends to plus minus y upon x. So what is this limit? What is y value? X upon under root x square minus 4. But x is in denominator, so write x. So this will be cancelled out. Limit 1 upon under root x square minus 4. What is this? This is 0. Okay. So this is 0. Now what is b? So this limit exists. So what is b? B is limit x tends to plus minus infinity y minus ax. So what is this limit? X tends to plus minus infinity. What is this? Y. This is 0. So x upon under root x square minus 4. Okay. Sorry, I have taken wrong question actually. I should take here x square. If I take x square, this is plus minus infinity of x equal to 2 is a vertical asymptote. Similarly, when x tending to minus 2, it is also plus minus infinity. So this is also vertical asymptote. Now we are taking x square here. So this is x. So this is x here. So after taking it, okay. So we need to calculate. You see that in first example, in first example, we have to calculate these two limits separately. Okay. These two limits separately, and we have to say that y is equal to ax plus b is an asymptote. Okay. In first example, letting limit x tending to plus minus infinity is giving common value. There are a common value and b common value. They are constant. We are not getting two distinct limits, but we have to individually calculate to plus infinity and minus infinity. For example, if I will take here plus infinity, so what is this? This limit is nothing but, after solving it, what you will get? To take x common, so this is limit is 1. Okay. So plus infinity. Now I got a value, this exists. So limit exists here. Okay. So this is 1 into x. So what you got? Limit x tending to infinity. So this is x minus minus 4. So make it conjugate, what you will get? After make it its conjugate, what you will get? Limit x tends to infinity, x square minus x square, x square minus 4 upon under root x square minus 4. Okay. So solve it, what you will get? This is actually x square. This is x square. So this is x to the power 4. So x square minus 4. To take x plus x under root x square minus 4. Okay. So limit x tends to infinity 4x square. You take x common here, so you will get, you take x common here, so there will be x square. So this is cancel out. So limit. So this is 0 actually, because this is 0. Because this will be a 1 here, 4, and this will make infinity. So b is equal to 0 you are getting. This adjusts. So y is equal to ax plus b. A was 1, okay, and this was 0. So this implies y is equal to x is oblique asymptote for the curve. Okay. Now we have to calculate for x is equal to tending to minus infinity. So we have to calculate this limit also. Limit y upon x. That is limit x square x. So what is this? This is limit x square x. You take this common. So this will be mod x. So this is cancel out. This is this. Tell me what is this limit? This is -1. This limit is -1. So this is x. How to write mod -x? This is -1. So this is -1. So this exists. This also exists. Earlier was existing. Okay. Now A exists. Again, you can now calculate B. B is limit x stands for minus infinity, y minus ax. So this is limit x stands for minus infinity, x square minus 4, and that is plus x. Okay. So make it conjugate. What you will get? Limit x stands for minus infinity, x square x under root x square minus 4 upon under root x square minus 4. You make conjugate, then what you will get? Limit x stands for minus infinity, x to the 4 minus x square minus 4 upon under root x square minus 4, x square minus x under root x square minus 4. Okay. Was actually, this was x square, and after taking common, we go there, x. This is x. Okay. This is x. So this is infinity. That is why b was 0 in earlier example. Now same here we are doing. So take x common here. Let me check it again. Limit x tends to minus infinity. I wrote like that. So this is minus 1. Now I am calculating b x square minus 4 plus x. Okay. So you check that in this case, actually from here, I was making mistake. This limit does not exist actually. You see that this limit does not exist. So what is this limit? Limit x stands to minus infinity x square. We take common. Let me check it again. Let me limit x stands to minus infinity. Solve it. So after making conjugate, what you will get? Make conjugate, then what you will get? Limit x stands to minus infinity. After making conjugate, we will get x square, 4x square, and in denominator we will get this. Okay. You take x square common here. We will get upon. So this is cancel out. But here, this factor is coming here. So this will be finite. And because this factor is coming, this will going to be 0. Okay. So at this. So what is A here? A is minus 1 here and plus B. So this implies y is equal to minus x and oblique asymptote for the curve. For the given curve. So what will be its limit? This limit is actually minus 1. Minus 1. That is, this will approach to minus 2. Okay. And this will approach to infinity. That is why resultant is 0. Okay. Here no horizontal asymptote because both the asymptotes are vertical. Oblique. So no horizontal asymptote exists. Because horizontal and vertical, horizontal and oblique asymptote comes together. But only oblique asymptotes are coming, so no horizontal asymptotes. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture.